Hey, Jeff Disher here again. I'd like to address something which was actually a question raised by a friend of mine. He was asking what programs actually do. So today I'm going to talk about some kind of basic entry-level stuff that you'd see if you were learning how to program at, say, a high school level. So this is all about the physical act of coding itself. So the first question I always remember asking when I was a child is, well, why not just write it in English? Why can't computers understand English when I'm saying something? Other people do, but why don't they? And the first thing to realize is humans are very good at making sense of ambiguity and a lack of precision or accuracy in what you're talking about. There's a lot of people kind of know what you mean, or they understand based on the context what you're saying. Well, computers don't have that background to fall back on. So when you're working with them, you have to be very, very precise and accurate. So they really only understand numbers, true and false, basic concepts like that, things which are expressible in switches, which is really all the CPU is. Programs right on top of this might be more sophisticated and can understand other things, but to actually write a piece of software at the lower levels, it requires just working with the basic assumptions the CPU has. So this is why if you actually look at a computer program, it often looks more like math, because as they said in Contact, math is the only universal language. It is accurate and precise. So how does this actually work? What does someone do when they're a programmer? Well, first of all, a program source code is what's called when you express a program, is written in a computer language. This could be C, Java, C++, JavaScript, things like that. There's various languages for it, and they all have different benefits, drawbacks, and situations where they're best applied. Now, this isn't anything too magical. Realistically, program source code is just written in a text file. Someone might use a lot of different tools to actually write this, but that's just to streamline the process and kind of eliminate or automate some of the more tedious aspects of the job. Then you take this text file that you've written with your programming language, and you give that to a program called a compiler. This turns the program source code into a binary file, which can be executed by the CPU, because CPUs only understand their native binary language. The source code program might be unambiguous, but it's made for your benefit as the programmer, not for the CPU, not for the computer. So the compiler bridges that boundary. This is the same whether it's going to a CPU or to an interpreter like a Java virtual machine or something like that. So what does this actually look like? What's a concrete example of what this program source code would look like? Well, here's a very simple example of a small C program. All it does is goes through the numbers from 1 to 5 and performs some basic math and does some output. So to someone who's written a lot of software, this looks pretty obvious what it does. But obviously, if you haven't worked in this before, it's completely alien. So all this does is it produces output like this. I ran this program earlier after compiling it with GCC, the compiler I use, and this is the output it produces. Okay, it's just walking over the numbers and multiplying them by themselves. Nothing that amazing. So really, that seems pretty simple. At the end of the day, is that all this is? Does it just come down to basic statements like that? And no, it's more complicated than that. There's the main thing to really consider is how do you solve a large problem? If you're trying to interact with something like a word processor or a web browser, and it needs to figure out how to position the text on screen that's been described on a website. Trying to solve those problems of where to put that and how to organize it and how you interact with it with a mouse and keyboard and all that, much more complicated. In some areas, some kinds of programs, it's not uncommon for it to become millions of lines of code. That was only about 8, I think. There's also something called computational complexity. Really, this just means the efficiency of the algorithm you're writing to solve a given problem. And this has to do with how certain problems, when the size of the data that they're working on gets bigger, the solution to the problem itself gets very, very slow. It doesn't scale, as we say. So there's different approaches to that, and that's an area which is actually much more like what you spend a lot of time working on if you take computer science at a university level. There's a lot of dealing with things like computational complexity, and it is very much abstract math and algebra. So the other thing is that, well, sometimes there's a different tool for the job. So sure, writing a little C program like that might work for a problem like counting, but if you've got if you're trying to like search for a certain keyword in a big web page or something like that, you're probably going to use a different tool. Experience and just kind of a breadth of knowledge is what leads people to use those other things. Sometimes they work better. There's portability, which means how well a program that's made for one environment, like say a Windows PC, will run if you try to run the same source code through a compiler for a Mac. And that's something which a lot of people spend a lot of time working with as well, especially in very commercial environments. Like if you worked for Microsoft or somebody like that, you'd spend a lot of time working with areas like that. But really, at the end of the day, the main thing it comes down to is patterns. How you understand a pattern in how to solve problems. There's things we have called like design patterns, for example, which is just how you think about how to design software to solve a problem based on how to think about the problem you're dealing with, but also patterns in the problem itself and in the data you're looking at. If you can come up with the right way of understanding or thinking about a problem, often you can come up with a very elegant solution to it. This is one of the things which is very, very important, and as someone becomes experienced, really their areas of expertise end up becoming, they become better at working with patterns and understanding them and seeing them, but also understanding how to organize and solve very large problems. So I hope to have another installment along this line which will actually deal with more things like how do software developers deal with large problems? How do they try and actually integrate the notion of patterns and how they solve things? But this is a good starting point. It just kind of gets down to okay, that's what I see on the screen if I'm a programmer, things like that. And what the tools generally do. If you overhear someone talking about it, you'll know, okay, that's the stage they're working at. That's what they're trying to do. So, as always, send me an email. I'd love to hear from you. Other than that, I'll talk to you next time. Bye.